Hi everyone. In this video I'm going to go through section 1 of your lab 2 handout, which is measuring the IV characteristics of the PN junction diode. So what you'll need for this part of the lab is a 1N914 fast switching PN junction diode, which comes with your kit, as well as a 1 kilo ohm resistor. Now the circuit that you'll be building consists of an input voltage and then the PN junction diode in series with the 1 kilo ohm resistor. Alright, so the very first thing that I'm going to do is I'm going to connect ground to this rail here. And we can do that by connecting any one of the 4 black cables from the 82, which represents the ground, to this rail. So that way this entire rail has a ground voltage of 0 volts. Once that's done, I'm going to connect my PN junction diode into my circuit. Now something to be careful about is that you'll notice there's a black line on one side of the PN junction diode. That black line represents the negative terminal of the diode. So make sure that the black line corresponds to the side where the negative voltage is, so that you'll be connecting the diode in the right direction. Now this is very important because this is the difference between forward biasing and reverse biasing the diode. So with that, I'm going to connect the positive terminal of my PN junction diode, that is the terminal without the black line, to the input of the circuit, and then I'll connect the negative terminal here. Once I have that, I'm going to connect my resistor. Now for this, we're going to use a 1 kilo ohm resistor, which has the color combination of brown, black, red. So take out a brown, black, red resistor from your kit and connect one side to the negative terminal of the PN junction diode and the other side to ground. Alright, so we have our ground set up and we have our PN junction diode and our 1K resistor. Now we have to actually supply a DC voltage to the input of our circuit. Now we could do this using the waveform generator, but since it's only a DC voltage, I prefer to use the positive power supply directly. So find the red cable labeled V+, and connect that to the input of our circuit. Now in just a moment we're going to head over to the Waveforms app, and the Waveforms app has built-in functionality that allows you to control this positive power supply to supply different DC voltages to our circuit. So the last thing we have to do is to set up our channel 1 and channel 2 measurements. So I'm going to connect the scope channel 1 positive cable, which is solid orange, to the positive terminal of our PN junction diode, and the scope channel 1 negative cable, which is orange with a white line through it, and I'll connect that to the negative terminal of the PN junction diode, which is the terminal corresponding to the black line. Similarly for channel 2, I'm going to connect the scope channel 2 positive cable, which is solid blue, to the positive terminal of the resistor, and I'll connect the scope channel 2 negative cable, which is blue with a white line through it, and I'll connect this cable to ground. Alright, so we have our circuit set up. Now we need to head over to the Waveforms app and actually supply a DC voltage to our circuit and then view the measurements on channel 1 and channel 2. So double click on the Waveforms app. Now you'll notice that on the left hand side there's a button called Supplies. If you click that, it'll take you to this panel, which allows you to control various parameters of the power supply. So after positive supply V+, change the voltage to 2 volts, and then click this button that right now has a red axis that says Master Enabler is off. Click that once, and now it should say Master Enabler is on, and we are actually supplying a plus 2 volts DC to the input of our circuit. Now the last step is to view the measurements being recorded on channel 1 and channel 2. And since these are DC voltages, we only have a DC voltage on channel 1 and a DC voltage on channel 2. We're going to do this using the voltmeter. So head over to the voltmeter and press run. And you should get measurements very close to 0.61 volts on channel 1 and 2 volts minus that on channel 2. Now this makes sense based on theory because we're measuring the diode voltage on channel 1 and the resistor voltage on channel 2. So if you recall the piecewise linear model, when the diode is forward biased above its turn-on voltage, it acts as a voltage source, which corresponds to the turn-on voltage of the diode, in series with a linear resistor. Since the 1N914 diode is made of silicon, its forward or turn-on voltage will be around 0.6 volts. And so this remaining 0.1 volt is the voltage across that nominal resistance. Also, we can see that these measurements are consistent with KVL in that we're applying 2 volts across the input of our circuit, and if we add up the measurements on channel 1 and channel 2, we get roughly 2 volts. So since we're happy with these results, record the numbers that you obtained from the voltmeter in table 1 in your lab handout, and now we'll move to the next measurement. So to supply a negative voltage to the input of our circuit, we're going to use the negative supply. So I'm going to turn this off and turn off the voltmeter. I'm going to remove the V plus cable from our circuit, and I'm going to connect the V minus cable, which is solid white, to the input of our circuit. This corresponds to the negative power supply. Now under negative supply, I'm going to change this to negative 2 volts. I'm going to enable it, and then I'm going to press run in the voltmeter. And as you can see, the voltage across the diode is essentially the entire minus 2 volts that's being supplied to our circuit, and we have essentially 0 volts across the resistor. And this makes sense based on theory, because when we supply a negative voltage across the PN junction diode, it will be reverse biased, and a reverse biased PN junction diode acts as an open circuit. And since no current can flow through an open circuit, no current will flow through the resistor, which is why our channel 2 measurement is essentially 0 volts. Now by KVL, if we apply 2 volts at the input, then the sum of these two measurements has to be minus 2 volts. That's why the entire minus 2 volts appears across the PN junction diode. So record the measurements you obtained for minus 2 volts in table 1 in your lab handout, and you can essentially do the same thing to finish up the measurements for minus 1 volt, minus 0.5 volts, 0.5 volts, and 1 volt. Alright, so this is it for section 1 of the lab, and in the next video we're going to actually build the envelope detector circuit and then take our measurements.